look at our schedule. I just handed back test number 2. So with a progress report about where you're, with approximately where your grade stands right now. The only things we have left before the end of the semester are Quest 5 and the final exam. Okay, so Quest 5 can boost your Quest average a little bit. The final exam is worth 15% of your grade. So you do still have a couple of opportunities to bring it up if it's not where you want it to be. And if you don't know how to figure out what you need on the final to get the grade you want, ask me after we finish the lecture part of class and I will show you how to do it. All right, so we've just got 4 more lessons, Quest, and then we will review for the final and take the final. Okay, so we are on lesson number 27, operations on algebraic fractions. So in this lesson, we're going to work on algebraic fractions, also known as rational expressions. We're going to be able to simplify them, multiply them, and divide them today. Okay. So here are some examples of algebraic fractions. 5 over x squared, x over x plus 2, x squared plus 5x plus 4 over x squared plus 6x plus 8. What makes them algebraic fractions versus just regular ordinary fractions? They have x's in them. Yep. A variable. Yep. So if you know how to do stuff with regular fractions, we should be able to apply all the same rules to algebraic fractions, right? So we're just going to need to do all the rules that we know about fractions plus all the rules we know about algebraic expressions. So we could evaluate, we could simplify, we can perform operations on algebraic fractions, just like we do with ordinary fractions in arithmetic. So we're just going to do a little bit of evaluating here. For each of these algebraic fractions, I'm going to find the value when x equals 2 and when x equals 5. So I'm just plugging in a 2 into each of these fractions. So I have 3 over 2 squared. How does that simplify? 3/4. Oops. 3/4. Yep. And now I'm going to put a 2 into the next fraction, x over x plus 7. So that becomes 2 over 2 plus 7. And that reduces to 2 over 9. Why do I keep putting the denominator on top? All right, and x plus 4 over x minus 5. That's 2 plus 4 over 2 minus 5, which is 6 over -3, which is -2. Got to go one more step on that last one because you can reduce the fraction. All right, so now we're going to do the same exact kind of thing, except this time instead of plugging in 2, we're going to plug in 5. So 3 over x squared becomes 3 over 5 squared, which is 3 over 25. X over x plus 7 becomes 5 over 5 plus 7, which is 5 over 12. And then x plus 4 over x minus 5 becomes 5 plus 4 over 5 minus 5, which is 9 over 0, which is undefined. Division by 0 is not allowed, right? I believe I've shown you why, but let's talk about it one more time. Can't see this too much. Why can't you divide by 0? Why can't I divide by 0? So let's see. If I want to do, say, 3 divided by 0, and I want to know what the answer is. So somebody suggested 0 might be the answer, right? So if I write this equation, 3 over 0 equals 0. 0 is the same thing as 0 over 1, right? Multiply both sides of this fraction by 0, or cross multiply, if you know cross multiply. 0 times 0 has to equal 3 times 1. And does 0 equal 3? No, so 0 can't be the answer. Right, so it can't be that 3 over 0 equals 0. Somebody suggested 1. Cross multiply that and you get 3 times 1 equals 0 times 1. Is that possible? Nope. So that can't be true. What if I pick some other number? What if I do like 3 over 0 equals some number that I don't know? We'll call it k, right? Cross multiply that and you get 3 times 1 has to equal 0 times k. Is that possible? No, no matter what I pick for k, that equation will never be true. So there is no number that you could divide by 0 and get as the answer. Just can't work. So we call that undefined. Okay. So algebraic fractions involve the operation of division. Fraction bar is just another way of writing a division symbol. So we have to make sure that the denominator does not equal 0. Otherwise we'd be dividing by 0. It's not allowed. So for what variables is this fraction, 5x over x squared minus x minus 6, not defined? It's not defined if the denominator is 0. You don't ever want that denominator to be 0 because then you'd be dividing by 0. So I just want to figure out when is that denominator 0. Right. Yeah. What x value, though, will make that denominator 0? -2. Anything else? 6. How are you getting these numbers?
-2 can't, because if you're squaring -2, you're going to have a
+4, yeah. And then subtract -2, and that gives you 6, and then -6 is 0. So it does look like x equals -2 is a solution. If you plug -2 in for x, you do get 0. Yeah. 3. Yeah, so 3 squared is 9. 9 minus 3 is 6. Minus 6 is 0. So -2 and 3 are definitely the two values that make the denominator 0. How did you come up with those? The quadratic formula, or you could guess and check. Some of you did that. Or you could factor it. Yes. Yeah, it's already set equal to 0. We could apply the quadratic formula. A is 1, B is -1, C is -6, or you could factor it. This would factor to x minus 3, x plus 2. And then you set each factor equal to 0 separately. I'll write those again later. So either x minus 3 equals 0, or x plus 2 equals 0, and you get x equals 3, or x equals -2. So those are your two x values that make that fraction undefined. Because if you put those x values in, you get 0 in the denominator, undefined fraction. All right, let's review how to simplify or reduce a fraction just with regular old numbers. 24 over 54. Okay, do 24 and 54 have any factors in common? 3, anything else? 6? I don't think 12 goes into 54. It does? No. Yeah. So let's do 6. So I want to rewrite 24 as 6 times something and 54 as 6 times something. So 24 is 6 times 4 and 54 is 6 times 9. Okay. So now that I've written that, where I used the same factor for both, I have a 6 on the top and a 6 on the bottom. What is 6 over 6 reduced to? 1. 6 over 6 is actually 1. So this fraction reduces to 4 over 9. Do 4 and 9 have any common factors? No, then we're done. We've reduced the fraction. So when we cross off those 6's, we're allowed to do that because 6 over 6 is just a fancy form of 1, which we call a foo-foo. Yeah. Okay, let's look at each of these fractions here. Are we allowed to cancel the 2's in 13 times 2 over 2 times 3?
Yes.
Yes. Yes, you are allowed to cancel the 2's in that case because the operation separating the 2 from the number next to it is multiplication. So this would reduce to 13 thirds. Okay, am I allowed to count? 13 thirds, you're right, thank you. All right, how about in the next fraction? Can I cancel the 2's? No. Why not? Because it's addition. They're separated by addition. I can't cancel the 2's. If you're ever tempted and you go, oh man, I can't remember when I'm allowed to cancel and when I'm not, just test it, right? If you cancel the 2's, the answer to this thing is 13 thirds, right? 13 thirds. If you don't cancel the 2's, the answer is 15 fifths, right? You add the tops, add the bottoms, then divide, and 15 over 5 is 3. Is 3 the same as 13 thirds? No, so it must be that that shortcut was not allowed, right? So if you're ever tempted or can't remember when you're allowed to cancel, just put in some numbers and check. How about in this case, 13 minus 2 over 2 minus 3? No. No, because those are separated by subtraction. Okay, so the only time you can cancel a fancy form of 1 is if the main operation is multiplication. Okay, so foo-foo, fancy form of 1, to simplify or reduce an algebraic fraction. So something that doesn't just have numbers, but might have some letters in it. You want to, again, same as we did with numbers, look for common factors. So that means we are going to have to factor stuff. Look for common factors in the numerator and the denominator, cancel common factors to simplify. So here's our first example. Big question, are the numerator and denominator both in factored form? No. Answer to the big question is no, they are not factored. Okay. So we factor. X squared minus 9, how does that factor? What? X minus 3, X plus 3. Yeah. I'm going to go through some of the factoring in today's lesson a little bit quickly. When you're doing your activities, feel free to take your time on the factoring, draw a box if you need to. I'm doing it a little bit quickly to make sure that you have time to do some things on your own. X squared plus 6x plus 9, how does that factor? X plus 3, X plus 3. Okay, do I have any common factors? The same factor on the top and the bottom. X plus 3, I've got a fancy form of 1. X plus 3 over X plus 3. So I cancel it, which means my final answer is X minus 3 over X plus 3. That's my reduced form of the fraction. Canceled common factors. So it would be like if I wanted to factor 12 over 16, if I wanted to reduce 12 over 16, 4 goes into both of those numbers, right? 12 is 3 times 4, 16 is 4 times 4. I can only cancel 4 over 4 because 4 over 4 is 1. This other 4 has nothing to cancel with. Does that make sense? Yeah. Okay. All right, let's do another example. 3x plus 12 over 6x plus 24. Are they in factored form? No. Okay, so we factor. So 3x plus 12. Ooh. First thing you should always check when factoring is for a GCF. Do 3x and 12 have a GCF?
Yeah, they're all divisible by 3.
They're all divisible by 3. Yeah, in the numerator, I could factor out a 3. So I have 3 times x plus 4. In the denominator, can I factor out a 6? I could factor out a 6. The GCF of the denominator is a 6. And I'm left with x plus 4. Do I have any foo-foos? X plus 4 is the same on the top and the bottom, can cancel. And then 3 over 6 reduces to 1/2. All right, one more with reducing algebraic fractions. Big question, 2 plus x over 2. Are the numerator and denominator already in factored form? Yes, there's nothing you can do to 2 plus x to factor it. There's nothing you can do to 2 to factor it. So the big question is yes, which means we're done, right? There's nothing you can do. There are no common factors because you can't factor. So this is 2 plus x over 2, already reduced. It's similar to if I gave you on an arithmetic test the problem 3/5 and said reduce that fraction, right? You can't. 3 and 5 have no common factors. They're both prime. All right, let's look at the algebraic fraction x minus 3 over 3 minus x. And we're going to plug in a 10. So I'm going to plug in two different values here, see what we get. So if I replace the x with a 10, I get 10 minus 3 over 3 minus 10. What's 10 minus 3?
7.
7. 3 minus 10 is -7, so I end up with -1. Yeah. Because 7 over 7 is 1, and I have a positive over a negative, so the answer is negative. All right, let's see what happens if I plug in -2. So I'm going to have -2 minus 3 over 3 minus -2. What's -2 minus 3? -5. What's 3 minus -2? 5. So -5 over 5 is -1. Okay. So it turns out that in general, if you have a fraction that looks like a minus b over b minus a, the answer is -1, right? Because you always are going to end up dividing opposites. One of the top and the bottom will be the same value, but one will be positive and one will be negative. So it's always going to give you -1. Looks like I deleted something I should not have. Here we go. Okay, so I want to simplify. Yeah, I know the answers on the paper. I got rid of it so that I could write out the work for you. Okay, so I want to simplify 64 minus x squared over x squared minus 6x minus 16. So if I want to simplify, the first thing I always want to do is ask myself, are the numerator and denominator already factored?
No, they're not.
No, so I go ahead and factor. Do as much factoring as I can. 64 minus x squared reduces to, this was on your test, close, 8 plus x, 8 minus x. Yeah, that's the difference of two squares. All right, and then my denominator, x squared minus 6x minus 16, how does that factor? X plus 2, x minus 8. All right, do I have any foo-foos? Do I have any factors that look exactly the same on the top and the bottom? Do I have any fancy forms of -1?
Yeah.
Yes. The 8 minus x and x minus 8, that fits the a minus b over b minus a, right? So these two equal -1, right? That fraction is -1. So my final answer is going to be -8 plus x over x plus 2.
Looking at the paper.
-1 times that, and they went a step further. So I've got my -1 times 8 plus x over x plus 2. And then oh yeah, then we take -1 is often just written as -8 plus x over x plus 2. That okay? All right. Moving on to number 11 here. Can you cancel anything in this fraction? X plus 5 times x minus 1 over x minus 7 times 1 plus x.
Yes.
You can't. It's really tempting to cancel the x minus 1 and the 1 plus x. Yeah, in order to be able to cancel them, they would have to look exactly the same, right? Or if my numerator were x minus 1, my denominator would have to be 1 minus x. It just has to reverse the subtraction. Yeah, if you want to cancel it.
X plus 1 is the same as 1 plus x.
Yeah, but I didn't write x plus 1 anywhere. In order to use this formula, this a minus b over b minus a, right? It just reverses the subtraction. There is no addition in the denominator, right? So here I have an x minus 1, right? So of x minus 1, if I was going to be able to cancel it, my denominator would have to be 1 minus x, but it's 1 plus x, so I can't cancel it, right? So x minus 1 and 1 minus x would cancel, but x minus 1 and 1 plus x don't. If addition is reversed, yeah, right, yeah. If I had like totally separate problem here, this has nothing to do with number 11, but no, that's okay. If I did 5 plus x over x plus 5, yeah, totally those are the same and you can cancel them. That reduces to 1. Okay, so to multiply and divide algebraic fractions. So we've done a whole bunch of simplifying. Now we're going to multiply and divide. Okay, so in general, how do you divide two fractions like 4/9 divided by 2/27? Flip and multiply. So you copy the first fraction, 4/9, that just stays exactly the same, and then you multiply by the reciprocal of the second fraction. So times 27 over 2. And then you can either just multiply directly across right now, or you could do some canceling before you multiply. It's going to save you some arithmetic work. So you want to cancel things on that common factors on the top and the bottom. So do 2 and 4 have any common factors? 2. So 2 goes into 2 once, and it goes into 4 2 times. Right? And then 9 and 27, do they have any common factors? What? 3 or 9, yep. So 9 goes into 9 once, and it goes into 27 3 times. And then you can multiply across. So 2 times 3 is 6, 1 times 1 is 1, and the answer is 6. So we do a similar thing when we're going to multiply or divide algebraic fractions. All right, so I've got 15 times x to the 9th times y cubed times a fraction 2 over 35x to the 4th y to the 10th. So first thing I think I'm going to do is do 15 x to the 9th y cubed and write that as over 1. All right, and now I'm going to cancel common factors from the top and the bottom. So start with the numbers. 15 and 35, any common factors? 5. Okay, how many times does 5 go into 15? 3 times. And how many times does 5 go into 35? 7 times. Okay, so we dealt with the numbers. Let's move on to the x's. I've got an x to the 9th on top and an x to the 4th on the bottom. When you're dividing, Yeah, when you're dividing like bases, you can subtract the exponents. So I've got x to the fourth on the bottom, that's going to go away, and this one's going to become x to the fifth. Yep, and then I've got y cubed on top, y to the 10th on the bottom. Subtract and you get y to the 7th. Where should I put it? In the top or the bottom? In the bottom. Why? That's it, where there are more of them. Yeah. So once you subtract, there are going to be 7 left, and they're going to be on the bottom. So this becomes y to the 7th, and that just goes away. So once I multiply these, I have 3 times x to the 5th times 2, which is 6x to the 5th. And on the bottom, I have a 7 and a y to the 7th. Yeah. Yeah, so if you do 3 minus 10, you'd get negative 7. And that would be in the numerator, right? Because you did the numerator minus the denominator. So you'd have y to the negative 7 on top. And then you would just move it to the denominator to make it positive. Yeah. Some people might prefer to do the multiplication first, multiply the two fractions together, and then reduce it, which is totally fine also. All right, let's look at this next one. Be sure to factor everything first. So I've got two fractions. The second one is going to get flipped, and I'm going to change it to multiplication. So look at 4y squared minus 1. I'll do each thing in a different color. 4y squared minus 1. That's the difference of squares. 4y squared, what's the square root of 4y squared? 2y, and the square root of 1 is 1. So that one is going to factor to 2y minus 1, 2y plus 1. All right. 4 minus y squared. That's also the difference of two squares. Close. 2 minus y, 2 plus y. Because 4 is the first square that shows up, so it's going to be first in the factoring. All right, let's look at 4y plus 2. How can I factor that?
Y plus 2.
It's got a GCF, yeah. And I'm going to move it to the bottom of the fraction because I'm flipping this fraction over and changing it to multiplication. So when I factor that, I'm going to write it as 2 times y plus 1. And then this last guy, y squared minus 2y. It also has a GCF. What's the GCF of those two terms? Y. So it's going to be y times y minus 2.
So going to be 2 times 2y plus.
Yeah, thank you. Yeah. All right, so now I look for foo-foos. Okay. I've got a 2y plus 1 on top and a 2y plus 1 on the bottom, so those should cancel. That and that. Nope, they're gone because when you have something over itself, it reduces to 1. Yeah, so those are just gone. The 2 stays, yeah, from the GCF. Yeah. All right, now I've got, do I have any 2y minus 1s in the bottom? No, okay, so that has to stay. Do I have any plain old y's in the bottom? No, so that has to stay. Y minus 2, do I have any exactly y minus 2s in the bottom? No, but I have 2 minus y, right? I have 2 minus y. So this guy, I'm out of colors here, and this guy are a fancy form of negative 1. Y minus 2 over 2 minus y. When you change the order of the subtraction, it becomes a fancy form of negative 1. So those are going to cancel and create a negative. And now I'm just going to write out everything that's left after my canceling. I've got a negative sign. I have y times 2y minus 1 And on the bottom, I have a 2 and a 2 plus y. All right, that's it for the demo. So I'm going to let you get started on your activities. Let me know if you have questions, as usual.